Okay, so we multiply by the secondary diagonal, right?
But we also need to transpose the first. You see? Because the matrix
Oh,
A,
okay.
so you do transpose of A and then
Lemus,
multiply that.
would you like to check our sound before like going further?
Yeah,
Oh yeah,
I won't do that. But Baguette, start explaining how the heck we're gonna transpose it. If we have something like in.
right. Okay,
Yeah,
so let's just
Magenta, try to explain
recap.
me so I can like
Let's
also
just
talk
recap.
for he to grab my voice and then yours. So I think he got
Alright.
my sample for now, so go on.
Okay, so let's just recap. So last episode we finally defined the idea of a piece. So we're gonna be basically having kinds of pieces in this class here. So we're gonna have symbols that will define each kind of piece.
Yeah, it's fine. Not to make sure that my audio is the same level as Maguetta's.
For me it is.
Okay, so it's fine.
No.
Okay, so let's go.
Okay, so we have a position. So this is gonna be the initial position for a piece. So we defined it previously that it's gonna be 0, 4 because when we run this, let me show here. So 0, 4 would be 0, 1, 2, 3, 4, right? So we're gonna put in here up until the 4th row, right? I think that was it.
Yes.
So we need to alter this as well. Let's go first here.
Yeah, just put 24 instead of 2010 there.
Hey folks, now that we have only 3x3 in some cases, it will not be really in the center, right?
Doesn't matter.
But it doesn't matter really.
Yeah,
unless we make a odd number here.
I don't think it's worth it.
Yeah, I also don't think it's worth it. Okay.
Okay, so and we have a representation which will be the list of zeros and ones. Actually the two-dimensional array. That's gonna be the representation of zeros and ones where the thing is there.
Yes.
So we have the kinds of pieces. So the T, the S. So these pieces here, they will be 3x3 because it's easier to rotate using linear algebra.
Yes.
And some special case pieces like the straight and the O, the block.
Yes.
We're just gonna handle like this because well, the block doesn't need to rotate, and the straight is literally just changing to just like literally transposing it, I guess. So
if that's the operation, we wouldn't even need the states.
Yeah, for this case, I think if we can just.
Oh, the square is also transposed.
Yeah, the square.
Nice, nice.
So we just check if it's either one of the.
Yes.
Yeah, well, the straight is the block will never change. Like it's
the block will never change. Yeah, so with the 4x4 pieces, the rotation is transposing. With the 3x3 is the operation that you're going to be explaining further on the line.
Yeah. So with the help of our amazing viewer, we could make a method to instance this commander. Let's give the credits.
So yeah, no, totally him, totally commander, poggers.
We can make like a piece, and we start with the representation. Okay, nice. So today the main goal, if I may say that way, because we had many goals.
Yeah.
So the first goal is this. So spawn a piece in the board. So we start by the initial position in the matrix, and we do some logic to actually draw it. We decided that we will draw the piece in the like zeros and ones, just in this thing here, and we're gonna keep printing on this thing until we like actually do some graphics out of this.
Yes.
Because if we can port this to graphics, it's not gonna be that hard, I guess.
Yeah,
the hardest part will be OpenGL, I guess.
One question. Okay, go on.
Okay. So and the rotation. I think we can do the rotation after this. I don't think we'll take too long on like
spawning a piece.
That's a rotation without checking the collision, right?
Without checking the collision.
Checking the collision, yeah.
Yeah, collision is next step.
Collision is a way other hell. So let's just make I know you can change, but let's just make a var. We can change it later. Let me see. I think I did some. Okay. Sorry. I'll call it board. I don't know if Tetris is called board. I'll just use board.
No, it's fine. No, it's board. I think it's board. Yes.
So let me just kill this, and we can keep using the stuff in here. All right, cool.
Nice, nice.
So
Okay, so to spawn a piece, I think we
can
could.
make
We need two things, right? We need
yeah.
the kind of piece
in a piece and a board.
and a board. What do you think, Nathan? Go on.
So the
Yeah, that's literally like getting the arguments and instantiating the object. It's literally that.
I think we don't need to do it like spawn. Differentiate between the spawn and maybe. Well, let's just do this. Otherwise, we can change it later.
Yeah.
Spawn piece. So we receive a board and a piece, and we basically need to go set using the aref. So we get the references for the positions in the board, and we need to change this. So we were thinking we need to do now.
Wait,
start
Mageta,
writing.
one second. Does it make sense for us to make this relation of spawning a piece? We need a board and a piece, because as far as I know, our
The board is actually global, so it doesn't matter.
like
But anyway, go on.
I mean, in the sense of the board that we are talking here, I'm not talking about the grid. I'm talking about
Okay.
board that as of
board
now
is actually
is
the grids.
no. Wait, listen to me. I'm talking
Okay.
to board in the abstract sense. Like now, it is this the representation only. But suppose in the future it could be this and something else. So I'm talking board in abstract way, not what is declared that, right?
Mm-hmm.
So does
Okay,
it make
go on.
sense to make that relation between the board and the piece regarding spawning a piece? Because
Yes.
as of now, the board is only a representation. It is not storing a piece. And as we know by now, like spawning a piece, it doesn't mean that the grid will have the ones that the piece has. This only happens when they collide, right? When they collide. So what is the sense of having a board to spawn a piece?
Collide. What collides with
No,
what?
no, no.
I
Let
don't
me try to
understand.
rephrase it. I got Nathan's idea. It's because Nathan is differentiating, explicitly differentiating a piece from a board in the sense that the board contains all the ones like at the bottom after collision. So when a piece collides
Oh, okay.
with everything else, it becomes
Mhm.
part of the board.
Okay, I get it.
But that's an interesting point of view. But I don't know how we're gonna. Like, I think it's impossible to not put a piece inside a board.
No, that's only the draw. For example, what is to draw? You
Actually,
draw
no,
the
here-
board
that's what
and
I-
you draw the current
Okay.
piece, and then the result on the screen will
Yeah.
be like a fusion of those two data
Yeah,
structures.
what I was thinking is like taking this initial position and modifying this initial position and just displaying. Like this spawn here is just literally draw to this like grid, board, whatever. Just draw here this thing at this position.
No, that's the thing. I was also thinking about that, Mageta. But what Nathan's
But
proposing
that's just
is
saying draw
is-
piece because the piece has the position.
Okay, but let me try to explain to Mageta. Mageta, what Nathan's talking about, correct me if I'm wrong, is instead of treating the piece inside the grid, we handle that separately and we just display on top of the grid.
Yeah.
You see? It's almost like the piece is in a void.
Yeah,
It's
but like that's
like-
what I'm saying. We keep changing this, and then
No, we
like, to
change it-
display. We will need to do the display it anyway.
Yeah, but see, display is not the same as spawn because in spawn is just having the piece
okay, I
instantiated.
get it.
we can.
Yeah,
Or
this
I
time
think
it's
it's
like
useful to
lifting-
change the name to
lifting
instead of
piece, right?
spawn is to display piece. Because without
make it
display,
easy.
how the hell are we gonna debug? You know?
Just one thing.
Yeah.
If we are like in agreement, then the spawn would literally be the same line as the make instance, but with one word less, right?
Yeah, the spawn would be this. Like
Mm-hmm.
we have like a queue, something like this, right?
Yeah,
That we
you
keep
only pass the
receiving
kind,
pieces.
right?
Yeah.
Yeah.
Yeah, makes
phone
sense. Makes sense.
And Well, let's just make it real quick.
Really interesting perspective, right? To
Yeah,
that
I agree
Nathan.
with that.
I think we have that on the video, Lemos. Not sure.
Okay.
I don't think that the guy said that we treat the piece in a void and we just display it on in a different, like it's almost like we are dealing with them separately. It's like a
Well,
more
they are two different data structures, but it could probably be on the video because I'm not sure if that's my idea. Maybe it's from the video.
okay.
Okay, so let's just find a way here. I'm just concerned with we need now to save how everything is at the current moment and keep like running it and keep saving this, right? For like ticks. So we
No,
need to
not
Or
save what
ticks
was
for
the
now?
previous state.
Wait.
No, here's what I'm saying. We need to save this board all the time. It's a global thing, so we can modify it. And we need to keep modifying this by writing something. That's what I'm saying. And we need to keep track on this. So we need to put like to keep what are all the pieces and their representations on the screen.
I'm not understanding you, Magita. Can you try to rephrase it?
If we're gonna let me try to find it that way. Sorry. We have this thing here, right?
Okay.
So this is the board. So this is the thing we're gonna display. How do we display something here? We basically get what I was thinking. If you're thinking something different, just voice it out. But what I was thinking is each piece they have this thing here, the initial position, right? So when you first insert it on the board, you basically start writing the piece, this representation here, from this piece, from this thing onwards, right? So we start by here, like we can change this, but we start by here and then we write it here, something like this.
Yes.
What is
and then the question is, how are we gonna do this?
Wait, folks. Wait. Like I'm not understanding perfectly, so I will try to like say my point, and maybe it's the same. And if it's different, you will like perceive the difference. The thing I was thinking is, we have like the ticks, the quote unquote ticks, will be just us like calling functions multiple times instead of actually defining a thing for that. Just because it's easy, right? So what we could do is we have the board, we spawn a piece, and then we do something like, advance state of the piece, and then draw the board, and then we pass the board and the piece, and then you advance the piece, draw the board, advance the
and
piece,
to save the
draw the board.
Meanwhile, but then
No,
you
no, no.
lost the
What do you
idea.
mean by to save?
No. Wait, Nathan. It's because, Magetta, what Nathan is thinking about is the exact same thing as I explained in HVita. So it's immutable, you see? Instead of changing the same global variable board, we make a function that picks a board and it returns a new one.
No. Wait. It can be that way, but the thing I said, it doesn't need to return the immutable one. It can be mutable, but it works the same.
But how do you plan on displaying something that you don't know what is the current state? That's what I'm confused.
Wait, how don't we know? Well,
You just start with this. Oh, okay. Let's go with the first one. So you start with this.
Okay.
This is all zeros. How
Mutable.
do you write? Okay. How do you write something here?
Well, I just modify
Display
it.
piece.
It's mutable, so.
Yeah. Okay. You modify, right? So what do you do on the next one?
Well, actually,
Without mixing the
wait.
pieces,
As of now, as we don't have collision, we will not modify the board. You see why?
No, Magetta, it's because remember, Nathan is treating the piece and the board separately. So we only change the board. We only change the board, Magetta. I think I'm totally getting what Nathan is talking about. I'm gonna try to explain. The board itself is composed of only two things: the empty field and the pieces that already collide. That's the board. The board is only composed by that. The piece itself and the rotation management, it's happening separately.
It's outside. Yeah, I get it.
And then to make them sing together, we just put them one on top of the other in the display OpenGL part. You see?
Or
Okay,
in
but
the
I want
print,
to
in this
do
case.
something to debug.
Yeah, I
So-
also want to do that. So what we are proposing, Nathan, is to make a function called display, which basically puts a piece inside the board,
but it's not modifying the board.
but it's not modifying the board.
Okay.
Well, that's our display, right? That's what I said.
No, but we are trying to rephrase it to see if you
we
understand.
were like. There
Oh,
was like
yeah,
a
so
whole
you
new
were talking about
confusion
the
just
same
to say,
thing.
okay, print the two things together, but then mess with them. Like, that was it.
Well, if your display it's literally like printing both without modifying them, then it's literally what I was thinking about.
Okay, so let's just go. We're just gonna
So,
display them, but not change them.
so let's see. We need to learn how to use properly the function aref. We use here.
By the way,
so we have
that's-
aref and setref.
Folks, by the way,
You want
that's
to?
trick to do in the terminal, right? Because like when we are dealing with the OpenGL, we could literally like draw the grid and just draw the
Top of the
pieces
other.
on top of it. But in the
Yeah,
terminal,
here we're gonna
maybe
have to-
would need to like copy the grid and then like add the thing in the coordinates and then draw this clone that we did, right? It would not modify the global one, would be one just temporary, just to draw it.
Yeah,
It's
that's the goal.
So
That's the goal.
I think we'll need to access the position. Let me just see here. Aref. Then we have the object itself. Let me see. So aref receives an array and subscripts, which I think will be.
can you explain what a ref is?
Aref is
Run,
basically a
it's-
function
yeah.
to access an element in a specific index.
Oh, okay.
This. I don't know how to do this. Let
No,
me
no, no.
see.
Are
I
you
think
trying to make a 3x3
dimensional-
grid?
Yes.
We need to do
Let me
the
see.
tuple thing. You look at the
Okay,
line
so-
14 up.
Line
see?
14 up.
Yeah, on the left.
Which
On the
one?
left.
Okay, on the left.
You see there, make
14.
array and then.
Oh, okay. I was trying to do with the thing. That's why I was complaining.
Yeah, exactly.
3 by 3.
We
But
need to
can we
we need to see if
pass-
aref works with 2 dimensions though.
Yeah, it does. Okay.
Oh, nice.
So let me
Maybe it's
print
arbitrary,
the-
Lemons.
Yeah, it kind of makes sense to be arbitrary.
Let me actually do this first. So let's just.
But hey, I have a problem with this.
Hmm?
I think we're gonna have a problem. You know why?
If-
Because how the heck we gonna know, aside
Hmm.
from the initial position, where to print things? Because the dimensions of the grid are not the same dimensions of the piece.
Well, it doesn't matter. Like we have the initial position, and we can what's the name? Like go through the data structure and like translate into the grid, right?
We're gonna have to do some arithmetic operations, man. I think.
Ah,
Because the grid, it's like 24 by 10 and the piece is 3 by 3. But the piece doesn't know it is in the center. You see?
wait.
Yeah. So
Man, you can literally do
Wait.
do the following. You like I'm not sure if we have that function exactly, but I will say that one. Suppose we do a iter I, like in F#, like we are iterating over a data structure, getting the indexes that we are right now, right? And then we just draw on that plus the initial position, right?
yeah, so the initial position map's already right. So we can just keep adding here positions. So like 0 to
Like
E,
on the loop,
J to.
the iter I loop, you just get the indices plus the initial position, right?
I don't know
The
how to do a
indices will be the
iterate. I
padding
know we have
from-
map.
Mhm.
We have map. Nice.
Well, we have map car. Like, but I don't know how to do with indexes though. We need to look at the docs.
Okay.
Oh, okay. So I was testing here, and we can access like this. So we get the reference of the position 1, 2, and then we can set with a thing. So let me just put like this, and oopsie.
Oh, in last case, you
Alpha.
can just use the fold, right, Lems?
Yeah,
Mm,
it's the same.
fold? What do you mean?
Yeah, for the indices.
A
we
folder
just
to
leave a
get the
state.
index.
Well, if you don't have the map yet,
Oh my
yeah,
god,
make
that
a
would be
fold, save
ugly.
it as state
Oh
0.
no, man.
What do you
Ah.
mean?
No, 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 no.
Yeah, man. That
No.
works.
No. Just don't.
Functional as in it just works. That's my
Holy no,
motto.
no, 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 no.
All right,
no.
so let's make the thing here.
I would be so disappointed if Lisp doesn't have any sort of index management, man.
I just look for map E, something like this.
Yeah, I'm trying to find here.
Iterate arrays in Common-Lisp.
Actually, we can do without the map. We have the loop as well. Loop. Yeah, we were doing it wrong last time. It has like some random words like repeat, for example, is in there. You can do like collect. I think we were using collect though. It has like good like keywords to help us.
Well, if you
Let
can
me
get
just
like
write
the
set.
number of rows and the number of columns, right, of the piece dynamically, then we can use the for. Like 0, 2 rows, 0, 2, right? A nested for loop.
Let me just get the initial position here. I think let was like this. Initial position.
But initial position is always 0, right?
No,
No, it's
not
not.
necessarily because
No.
this
Initial
time,
position
this
that I'm saying, it's like
no,
the
it's
loop.
off the piece
Oh, okay.
because this piece could be like I don't know floating somewhere else, and then okay, so we just get the boss out of the. This is a bad name, man. We do really bad names.
We could
piece.
put position if you really want to.
Yeah,
I'm not against.
Why was not
necessarily.
I
position,
think
by the
we
way?
did position because there's already a function called.
Oh,
yeah, that's true.
that.
I'm not sure though. I think.
No,
it was
but I think
conflicting something.
no, but I think that was the case. I think yeah.
Anyway,
Which is
so we
sad.
made the let. Let me just see if we can just print this thing. Because I don't remember if the initial position and the thing is not showing. I think I need two here, but let's see. Does it compile?
Can you already like destruct that with the let?
Just a secondo, and I'm calling like a normal func. New. Let me pass a piece. Do we have a piece that I defined here? Oh, of course I destroyed it.
No,
Oh,
but you
this
can
is the
spawn
spawn. Yeah, cool. So spawn. We're using like indexes like this, right? L.
Yeah.
piece. Oh, but L is. Let's draw something else. S.
Yeah. Okay.
Just some-
Okay. New. That's wrong, right?
Yeah. That's wrong.
Wait, you are not. Okay, display.
Initial position. It should be displaying at least. Actually, yeah, I demanded it to display, so it should be. I don't remember if he has like 2, man. That's the problem. Okay, yeah.
Oh, it worked.
So he has.
Nice.
Yeah, because it's a list of lists in here. So it's a list of definitions. I forgot about this. Okay. To closure, man. Closure creates this.
No, wait. Can you repeat what was the problem?
Here, we need a list of lists to basically assign, because when you're going to be assigning, you're going to be assigning like X this. In closure, you just do like, closure it's like this, let, and then you do X1, blah, 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 and then you do like, I don't know, plus 1X, stuff like this. You see, you don't have like this. You don't need to do this in closure, stuff like this.
Oh, it was parentheses then. The problem.
Yeah, parentheses.
Ah.
Yeah, Lemos. You solve it
no,
by
it's a
putting
functional
parentheses, but it's not the problem. The problem is that like it's a list of definitions, not only one.
Yeah.
Okay.
Okay, so that's it. It's returning the initial position.
Yeah,
Cool.
now there is a thing. Can you already destruct in that let? So like initial X and initial Y or something?
Like assign the X and Y, right?
Mm-hmm.
We could do this. Let me.
Oh, can you do that also in, well, if you don't have the destruct there, like in place, you could
Okay.
you could just do like in
Do
other
car
definitions, right?
Wait, did I kill a parenthesis? I think I did. Oh man, I'm stupid.
Too much parentheses.
No, this is parentheses hell. Totally parentheses hell.
Because I'm not using the strict mode, like I did activated, because it's annoying to cut stuff because I don't remember the key bindings. And I think we have a problem because Cudder. Oh man, yes, we have a problem. Let me just
Don't we
print
have
Cudder.
tuples in?
I think we do, but let me just see.
Yeah, but then you just do like cuddle and car, right? Like you receive a list with one element, right?
Wait,
Then
you
you
got
just
an error.
do another car.
The value 04 is not a function. It cannot be defined. Oh, this is a... Man, why do you do this? Just, it's a vector. Just define the thing. And compilation failed. Illegal because this is not a list. Ah. I'm suffering here. We are all suffering. That's what you should say.
I don't know. I think
All
it's
right.
going like
Yeah, so
much
we need to
better
now-
than the other time.
We just need to dismember now because this is a list because Cudder gets the tail.
But
and the
don't
tail
we
is the
need
list.
just apply another car?
Yeah.
Yeah.
So that's what I wanted to
That's,
have. I have Cudder.
Oh
no, no. Oh man, that's so atrocious. Like, oh my
That's
god.
actually exactly what we need, but it's such a weird name.
Oh, look at the variety we have.
Oh no, man! Like, I'm sad. I'm sad for the person who needs that kind of stuff.
No man.
It's amazing. It's all macro generated.
No, it's amazing that we have that, but it's not amazing have to use that.
Man.
All right, so
I really don't like
let's
this.
see
But okay.
here. Oh, man, this
Okay.
is beautiful.
Okay, and
Okay,
we're
so
making a
let's
function
see.
just to debug, right? So it's beautiful
Yeah,
twice.
So I just got the thing. So now we do the proper logic. So what we need to do is basically map the board. That's really bad because we're gonna map the whole board just to like display something.
No, but that's a
no.
trade-off. That's a
Wait.
trade-off.
Mm,
We need to accept that. That's a trade-off.
So let's do a map.
wait, folks. But we are thinking about the part of like showing the board already. But before that, we need to like clone or copy this board and like how can I say? And set
the problem is that
the
this thing
ones
is
of the
global,
PC in the no. But can't you clone that?
Global. Well, I can.
So
But
I don't think it's worth it though.
No.
Yeah,
But
I
man, like see, one approach that you could do is you clone the board like with a function, I don't know, like clone the board, and the result of that, you will write the piece in it, and then you draw that because drawing that is just going through a for and well printing on the screen, right?
We don't need to do that. That's the thing. We can just transform the def var to a def fun, and then it's a function that receives unit, and then
board.
no, it's a function that receives
visual
unit and
board.
makes a board. Yeah.
But we need to update that anyway, Lemos.
but
Unless we are
not
going
now,
to do
man, like-
immutable operations in it.
Dude, not now. We don't care about this now.
Oh
Yeah.
yeah. Right now it would be like a constant, right? Yeah, makes sense.
So,
Yeah, that's it. Make board, and then you do another let. We don't have to pay to pass as a dependency for this function. We can just do another let. Because again, this is just for debugging purposes. We're not gonna use this because we're gonna treat the piece and the board differently.
so there are some differences here. So I need to know what is the difference between each one. So
I think you don't want map, man, because I think what we want
Yeah.
is ether.
oh, because we don't want to change, right? We just want to. But wait, I'm gonna be mapping the board, which is this guy.
No, yeah, but we need to know where we are, right? Where are we? Sorry. We need to know like which position are we?
just need to match, like.
Yeah, but we need the
Oh,
indexes.
okay, I get it.
Can we-
Because we have the X and Y, right? That's when
Yes.
we start. And
Yes.
where we start right in the thing.
Yeah, exactly, but we need to check for that, right?
Yeah. Okay.
So that's a problem. That's a problem, you
We
see?
can access the positions. Oh man, I'm too ill accustomed. Is that a word? Like too much spoiled. Spoiled. I'm too spoiled.
Okay, so what we need to do? It's actually what I said. It's not as trivial as I initially thought, right?
Wait,
Because
folks.
we just need to do a lot of comparisons and things like that.
No, wait. The way I'm thinking, I guess it's easier. Like, the way I'm thinking is you do a for inside
Let's
the
do here.
piece, and you set those values into the board. Not a global one, but see?
No, but that's the thing, Nathan. Because we don't. How are you gonna map the coordinates of the 3x3 matrix to the coordinates of the board?
That's easy. Like, it's literally, where are you going to set? I'm going to set to the current indexes of the 4 plus the initial position, because
Yeah, all of them will add the initial positions. That's right.
Yes.
But we just
because-
need to. Okay, even this line, right?
because
All of
like
them.
the indices of the 4 will be the padding from
Yeah, cool.
the initial
Okay.
position. Oh, are you going to use F?
Yeah, I was trying to think like types. Anyway,
We missed the types.
yeah.
Okay.
Okay. Let's do the. So what do we need to do? We need to first get the do just an addition, right, to x and y. To
Hey,
the
folks,
indexes that we
it appears that we have a first and the second function. Like commonly
first and a
say.
second.
Yeah, forgetting like the first and the second of the thing.
Oh, we have map car and map coder, I think. No, or map.
No, not regarding map stuff. Regarding the car and coder
Coder.
that we are doing
be
on.
here.
Oh, there's an alias for that.
No,
I think
it's
there's alt. You can do like
Oh.
alt 0.
Oh,
and
arbitrary
alt
one, right?
1.
and he's
Yeah.
also saying that we don't have a map for like
For indexes, right?
no, not that, but for like an arrays of arrays, like we
Oh,
have to
this is an
do.
array. Oh, yeah. So that's. Oh, man, that's terrible.
No, but
Let's
we
just
do
do a
have a
loop.
for, right? We're not gonna use a map because we need the indexes. There is the iter apparently. I searched it here. There is like a way to do it that you combine the iter with the loop, with the for, sorry, and then you can do things.
Yeah, you don't need ether if you have the for.
I think you do.
The
Yeah,
for
no,
is
no, man. Just
the
let's do a
heat.
loop, man. Just do a loop. Repeat. Let's do the dumb boy. If
Okay.
it is the dumb boy. Repeat 10. Let's just print something.
Yeah.
Do format no nil. Okay, didn't print anything. If I do this. Okay, so
No, but we still have the same
can-
problem. You still have the same problem because we need to know. We need to have a way. We need to have a label to access in the index. This is why
we do, man. We have the for e.
Okay.
From 0 to
And that's
10.
dynamic, right? The two part.
Yeah. We can do this. Can we do collect like this? I think it doesn't make sense. Oh, it does. Because it's collecting to a list. All right.
Oh man, well,
Two
what
to
what an ugly syntax is that? Oh,
Not
because they're all
really.
keywords.
a lot of
It's
columns
the same
randomly
thing.
distributed, man.
Hmm?
A lot of columns randomly distributed.
What do you
Uh,
mean?
We have column for column 4, column from, column 2.
Like
Ah.
Ruby does that thing.
Yeah, but then
but
you know my
Ruby is
opinion on
disgusting.
Ruby.
Ruby is disgusting.
Oh wait, I didn't get it.
Oh, but
No.
Ruby is disgusting.
Oh, disgusting. Okay.
This is the quote. What?
The
did I
form to
do-
evaluate it to maybe you're missing parentheses. Is that a thing?
Yeah, I would expect that the callback that you are passing would.
Wait.
I
what am I
also
doing?
think
Oh,
you're missing.
from
Oh,
So
okay.
we have there. See?
Okay, so let's use that to try to, like, I don't know, iterate through the whole array. But can we indent? Yeah, okay. Ah,
That's not bad, man.
it's gonna be 0 to x and then 0 to y?
No.
So
Those are the initial ones. We need to know
Oh,
the
yeah.
size of the.
Yeah, it's
Yeah.
gonna be 24 and 10 then, okay.
so
Ah, wait, what exactly? Oh, okay, we are just printing the bar by now. Okay, right.
Yeah.
yeah, we can take the size of the board. Can we take like size?
Yeah, do it
length,
dynamically would be a lot better.
length of the board, but this is the length of the board. Oh man, wait. Length of the board. Can we do this? Let me see.
I don't think that's gonna work, man. Because we need to have one dimension and the board is
No, but that's
2D.
okay. You can get the length of the board and then get like one example of how can I say? You get the number of
Yeah, it's an
rows
array.
and then you get one row and get the length of a row that you have the columns.
Yeah. Okay. Get the other one also dynamic, right? From the
Yeah.
thing.
Like, did it work? It like the length of the board?
No, because we don't have lengths of array. So that is the
Oh.
problem. Unless we have a function.
Wait,
called
isn't because
array.
length it would like calculate dynamically the size of the thing, but array is known at like
Total size. We have that.
because
man,
you don't
it's
need to
great selection.
calculate the size of an array, right? You already have it.
Okay, so oh man, this is bad. Like it shows, you see down there, but it's like the full size. That we only have this function here. Size, dimensions.
Oh. Yeah, he
Oh,
was
cool.
just talking
Oh!
about Commander.
Nice!
Oh man,
Commander
you,
literally
you
just
gotta pay
talked about.
attention. Gotta pay attention, Commander.
Okay, you can
so
do it. Okay, so just do
can we
another let,
grab
I
just-
think.
let me just see here what we get. Dimensions.
I think it's a list.
No, but what does this output? Like, just the dimension, not the dimensions. Okay, it's just a list, but then you have to access by like out 0 and out 1, right? Yeah. Okay, so
Let's do a let for that because look at that, man.
Yeah.
well, we can make it let. Yeah, we can put that in the let as well. It's yet another thing, but I think it doesn't matter.
That's a lot better than inline.
Okay. Let's just see this loop. And there's a bunch of warnings that we are just ignoring.
Okay, but now what we're gonna do now? We're gonna do an iteration. We now have a way to traverse, like to I don't know, iterate through the whole board.
It's just
And we
printing.
knew-
Like you print everything in a row and then you like break the line and print the other row.
Yeah, I think this should work, Maggot.
Yeah, it should work. Format T. I think it was this. There is nothing there, man. What the heck? From 0, make board. Is this function? Oh man, wait. I press to save.
Oh, Nathan, can you explain to me? Because I'm still not getting what you mean by just printing. Because
Okay. So you are iterating over the board, right? So
Okay.
you just print what is inside the board, if it is 1 or 0.
yeah, but we need to do a relationship between
No,
the
yeah,
piece.
that's what I said before. Like this is for printing the board, but what I was saying before is you get a board. In this case, as it's something like a constant or a board for now, you get the board, then you modify it to put the piece inside, and then you print that result, right? And how do you do to put the piece inside the board? You go a for through the wait. Yeah, you go a for through the piece dimensions, and then you just go doing a set inside the grid. And where do you put exactly the set? You know, by the current index plus the initial position. because all the indices will be like a padding from the initial position.
But do you see that what you said? You said doing a fourth through the piece, right?
Yeah, we have the dimensions of a piece.
Yeah, but we are doing a fourth through the board.
We need to do both. The first one is to insert the piece inside the board. Should be only one matrix, and then we need to iterate that matrix to print in the terminal.
Is that what we want, Nageta?
I don't know.
Wait, I wasn't paying attention. What was the thing?
Can you try to explain, Lemos?
Yeah. Okay. So apparently there is a thing that Nathan is saying about doing two types of loops. We have one loop to put the piece inside the board, and another loop for printing. Do you agree with that? I think we don't need the second one. We just return the new board, and then the terminal will print
I
for
don't-
us.
Oh yeah, I forgot to have that.
Yeah.
I forgot to have a Apple. So
Oh, man.
I totally forgot that. We can just
Okay, so,
evaluate
There's
the.
something I'm not getting. Yeah.
Oh
So I
no!
clicked here, so it's showing here. We just need to do something with it. So
I don't have a Lisp brain, man.
Okay. But then the 4 is through the pieces. Then
Yeah.
Okay, so Nageta, change the
Hmm?
instead of doing with the board in line 4 and 5 up, you just do the
Mhm.
piece, man. Piece.
wait, I just do the piece. I didn't get it.
I'll explain. Don't worry. So what we're gonna do? We're gonna iterate through the ones and zeros of the pieces, and we're gonna
Okay.
do a mathematical. We're gonna sum the initial position and set that on the board.
Oh, right. You just want to get the positions out of those things, summing by the x and y, and then you
Yes.
just access the positions, right?
And then you set in the board. The board that you just
okay,
created.
it's less expensive actually. I like
Yeah,
the
nice
idea.
then. Okay, so just put piece instead of board on the loop in the
Okay, but-
fourth.
Let's think here. You need to get.
Oh, by the way, Lemos, can you keep track of the chat? Because here I would need to show in the OBS all the time.
Okay,
I
so let's just wipe this out. So we need to get the differences from this thing here. Oh, I was using the board actually.
Yeah, it's the piece.
You just need to get the
So,
representation out of the piece, right?
Yeah.
Man, I keep using this, man. This is so annoying. Representation, like it already completes a parenthesis to me in the beginning. Like
Oh, I see.
when you're not expecting it, it's screws you.
I
Okay,
see. I
so
see.
we get the representation. That's it. Okay.
One question, Mageta. Man, what it happens when you have like different objects or classes with the same name of method? Because the macro that we will generate will be like the same name. Like what
When you have
happens
a
with that
same-
scope?
When you have a function that has the same name as a
Wait.
macro.
You have both. You have two classes, and both classes has a method. Not a method, but a property with the same name. Because a macro will generate accessor with this name of property, right?
Oh, okay, I see. When you have an accessor that has the same thing, right?
Yes, you have two classes with the same name of accessor.
Yeah.
The language is dynamic, so any object that you pass is fine, I think.
Oh, okay.
Okay, Commander is
I
saying
think
that
it doesn't matter.
accessors are generic functions. So
Yeah,
Oh.
matter.
okay, let's do what we need here then. So we have
Okay, so we are iterating.
okay,
we
and
have
now
the
we're gonna do the following. Inside the loop, you're gonna get the you need to get the one or the zero from the piece. You need to do like let something, let pixel, I don't know, whatever.
What's this? Okay, so we have. Let me see here. So we're gonna have the. I think. I mean, let's just get the representation here as well.
Yeah, you're getting faster noticing this thing.
What's the name of? How should I call this?
So
Embedded
much
name of
parentheses.
Piece
Nathan,
matrix.
give me a
Piece
variable.
matrix. Piece matrix.
Piece matrix.
And you do representation piece.
Nice.
And then yeah, you can remove from there as well.
but there's the thing. We're gonna set the positions in there, or we're gonna save collect then in somewhere else.
No, we're gonna do the following. We're gonna collect. We're gonna like get.
Okay, because if we're changing, then it would be a problem because
yeah, we're not gonna change. We're not gonna change the
the way I was
for the loop.
thinking is mutable. How can we do that immutable?
collecting. Like,
yeah, we're gonna.
let me show here.
Commander also said that you maybe want to collect it or something.
Like here, let me show to Nathan what I plan on doing. So let me just change these indexes.
The way I can see you doing immutably is putting some ifs.
Like, look here. You have E and J. So let's sum them both. So let me make that. So we want to map them both and sum. And close parentheses. You see? Like it's
Yeah,
basically,
but what we
reduce-
but we only want to use the indexes to mess with the piece and with the
Yeah.
matrix.
Yeah,
We
to
don't want
access.
to collect them.
No, we don't want to collect. Well, I was thinking of collecting the indexes and then using the thing that it outputs on this loop, so we can iterate again over the this new list, and this new list we set on the piece.
Well, why not
making
do
them separate.
just only one loop?
Because
Wait, I
one
didn't
is
get it. Why do you
immutable.
want to iterate again through the piece?
Let me try to explain to see
Um,
if I got it. Then Mageta can
No,
say
okay, I
if
get
I
it.
did.
You just want to iterate once and then get the positions, and then you just set
No.
the
I will try to explain what you are trying to do to see if I explain. So I'm explaining to Lemos. So what I think Mageta is saying is that he wants to do the iteration and collecting the indexes that you want to set, right? So he will do like the sum of the current index of the piece plus the initial position. So the result he will collect, it will be it will be like a collection of indexes that we have to set on the
Yeah, a collection of indexes that we have to collect on the matrix already, just mapping the ones. That's what I was
Wait,
Okay.
but
I don't
but
think it's worth it,
that's-
man. Let's
Yeah,
just do the
also-
zeros and the
doesn't
ones.
matter.
Hey,
Yeah,
also
just
other
listen,
thing,
just
Mageta,
listen.
because the result will give you one list, the list of the positions that you have to set on the matrix, but it doesn't tell you what is the position on the piece that you will set,
Yeah.
right?
Yeah, so it doesn't matter. Let's just do the.
Okay, so Commander gave another suggestion to change the 4. Instead of doing alt array dimensions piece matrix 0, you can just do array dimension piece 0. Dimension, not in plural. You see?
Dimension piece
And then you
zero. This?
then we remove the alt and the other 0.
Oh, nice.
Oh, thank you. What we would do without.
Man, our code would be even uglier without command.
Yeah, remove the S. Remove the S. There's an extra S in the. Oh man, I feel bad. There's an extra S. Yeah, understand that as you may please.
Extra S. I don't got it.
Just ignore. Okay, so we can loop. Let's just do this, man. Like, we're taking too long already. So
Extra S.
let's just we need to just get the positions and set them here. So we have the set F thing. So we can set on the thing.
You're gonna set
Actually, we can just
the
pass
first
the-
argument is what? The offset.
The first argument is the piece matrix. But here's what I'm.
Piece
Oh,
matrix.
the dimensions
No,
matrix.
man, it's not the piece matrix. The set. We're not gonna. We're
Oh,
never gonna
I'm
set the
stupid.
piece.
Yeah, I get it. It's
Wait,
the
board. Yes, and then we need to set it with the
The
value.
calculations for the
Side-
X and Y.
Can you
I think it
mutate
was like
stuff
this.
that you declared on let?
Hang on. Is it? Ah, man, I don't remember how we did it here. Let me see.
Nathan's
think
question
it's
is
okay.
important as well.
Hang on, because we did this. Okay, so we need to get the reference. So first a ref. Let me just do this. We need to get the reference of the board
No.
Ah.
Why we need to get the reference of the board?
because it's this.
Yeah,
this is like a pointer.
Oh, okay. So you are getting an access to the board. Okay.
Look on
Yeah,
the
you
apple.
get the positions on the border.
Yeah, and then
and
the
then
coordinates
you set the object.
is gonna be
Yeah,
I
because
plus
I was looking at
x.
this- Yeah. So, for example, here, I'm setting these. Let's set the 0, 0 to I don't know, D. And I think the
Alpha. What is alpha?
alpha is a verb. I defined it up there. I don't need to know. It's just this. See?
Yeah, it worked. It worked. Okay. Okay.
So
So
just
so
set
the
to-
coordinate, the
yeah.
coordinate that we're gonna use inside the aref is gonna be x plus I, right?
Yeah, so let me. Oh man.
X plus Y?
So
No, not
Yeah.
y. I.
plus
I.
E.
Yes, I.
Oh, okay.
And the other one's gonna be y plus j.
Wait, are you sure?
Yeah, I am sure.
Isn't Y going through the number of the rows?
Yeah, A is the row. X
But
is
X?
the.
Yeah, so I think that's
Yeah,
inverted,
that's
right?
No, that's right, man.
I also think it's right. We can check it
Yeah,
out later.
yeah, let's
we
go.
will discover. We will
Man, look
discover.
at this parentheses. I'm pissed.
Just look at the colors, man.
What do you
Ignore
expect, Lemus?
Just look at
It's
the colors,
Lisp, man.
It's like lambda calculus, man. That's it.
I
Okay,
don't
we're
like
just
this
gonna
argument.
Yeah, also.
Yeah, you
Now we need to do a get. How you do a
the
get?
haters. So we have the okay. Get we could use the good question because I want to do the both, right? So we can get the both of the aref as well. Let me see. Okay, can I get it back?
Okay, so
So-
aref, piece matrix, I and j.
I need to stop to cough. That's pathetic. Okay, aref, and then what we want to get? E
Oh.
and J. That's
Yeah,
it.
see if that works. No, you need to return the board. You need to return the board after all of this.
Well, this thing should already return the. Oh, this is just a do. L.
Like
No,
after
it's
the
not-
loop,
I
you
don't
can
know if, I
just
don't know if we need
return,
the
right?
program here. This is like
Yeah,
sequential.
The commander said that you don't need the prog n in the do. You can just write
Mhm.
multiple things.
Okay.
Cool.
Nice.
Oops, I deleted a parenthesis.
Okay, now you need to return the board. Is this that already
Mhm.
happening?
No.
Okay, so return
Now
the
we
board.
need- after the loop, we do. Oh, not the board. This board.
Oh yeah,
Yeah.
now we have the question. Like, can you mutate the board that is on declared in the let?
Mutate after we define. I think yes, because it's a position anyway.
Okay, so
it's a-
So it's like a pointer, man, in C. So I think you can.
Oh, okay, but yeah, you saying position instead of pointer is very confusing.
you can mutate
position
everything.
in the
Commander
memory.
said.
That's
But commander said you can mutate everything, and that's
Oh,
No.
and
that's,
well, it's handy here. Not sure if I would like that in a daily basis.
but that's a difficult selling point in our eyes. Man, if this works, I'm gonna be so surprised. And it does.
condition should be non-negative integer below 0. So we do something that the something was out of boundaries. Let me see.
Invalid index 4.
4.
But that does that make sense?
Maybe something is zero indexed and something is not.
Maybe. Let's see this. Oh wait.
Oh, length is, -1, right?
Plus. Yeah, I think we need the -1 here
Oh,
because when we try
yeah.
to set, we try to set.
Oh, I see.
Oh wait, not.
balls.
This.
This prefix
Don't we
notation.
have a subtract 1, a function that does that?
I don't know, but like this is readable, man. Come
Yeah.
on, you just need to get used to the parents.
Oh, we have something. No, we didn't. We don't want
we do.
Now,
We have a
wait.
one.
Yeah, sure.
We have a
But
one.
wait, now replace it. The I with the J.
Yeah, let's go with
I
not.
with
Yeah, the I with the
J.
J. Maybe you're just.
I-
Before
This is good, man.
really thinking about the problem.
Yeah.
Before really thinking.
Wait, what the
And no,
fuck?
same thing.
What the
Oh, yeah.
Same thing.
what the fuck are we doing, man?
Let's add a print here. Let's add a print. It's smart. It's a smart idea to print what we're doing.
Oh no.
Stop
We have
laughing of
all
our
number
disgrace.
ones in the middle of nowhere.
Stop
Uh,
laughing of our disgrace. Dude, this is wrong. It should be E, man. Doesn't make sense to be this.
Oh
Oh wait,
man.
wait, wait. Change the initial position to 0, 0 to help to debug.
0, 0.
Yeah?
What do you mean the initial position?
On def class piece.
Oh no, I think that's gonna. I think we need to do to test the arithmetics. We need to test the sum, not the.
Oh,
Okay,
okay. Makes sense.
it's useful. Okay, so let's
No,
print
wait,
that.
wait.
Let's
But
see what
if it's
happens.
0, 0, the sum will still be tested because will be just
Actually,
I
let's
and
check
J.
here. 0, 1, 2, 3, 4. And it started writing here.
What is the piece, by the way?
The piece is the
It's not
S,
S,
which
actually.
means
What?
that we should have a bunch.
Okay, let's look at the index. I should have
Commander
that down.
said that if you're starting the loop from 0, you don't have to specify.
Don't have to. Oh, we can omit the from. Oh, nice.
Okay, what happened there?
So
In?
yeah,
What?
I tried like new line, but
Oh, okay. It doesn't have escape
Oh,
characters.
wait.
It's a character,
it
right?
is-
Not a string.
I don't remember how to do a character, man. I think it was like this.
It's bizarre, right?
But anyway, that's
No.
fine.
But anyway,
That's
that
fine.
shows. Just
Uh,
stuff.
We have a 0, which is correct, right? And then we have x plus j. It's y plus j.
Oh wait.
Yeah.
Copied. Okay.
Uh,
0, 4.
which is fine, right? Which is fine. Starting from 0, is actually fine.
So okay. So the initial positions are correct because it's
They
both
are
0.
correct. Yeah.
Then it starts right. So,
1,
like,
5,
no-
2, 6, 3. Yeah, this seems
but
to be right.
we gotta also remember. Oh, let's print this as well because we gotta have in mind that this will not necessarily ever print.
Hmm?
Because we have zeros here as well, like in the piece thing.
Oh,
we
we could try that to debug. Go to the S piece and instead of zeros, put choose.
Hang on, let me just print the stuff here so we can see.
Wait, are you saying that if you try to print 0, it doesn't print anything?
No, he's not trying to.
No, what?
Didn't
No,
say.
man, I'm just saying that if you try to print 0, it's gonna write zeros to zeros.
Oh,
Yeah, and then it's-
okay, okay,
Don't see
okay.
anything.
Okay, so
Mhm.
Commander said that apparently the way to print new line is terpre, whatever that is. Terpre, is that a
Huh?
thing? Terpre, what is that?
No, wait. Why?
Terminate print, terminate line print.
Oh, okay, yes.
Oh,
terminate
okay.
print, yeah.
Ah man, why?
It's a cute name though.
Yeah,
It's not intuitive, but it's cute.
cute. The whole language is cute.
Ah, man.
Okay, print C.
Who needs a debugger? That's the thing.
I don't use a debugger. I have types. Types don't need debuggers. I'm
Don't-
joking.
Yeah, but we don't have here. So okay, so maybe it's not terpri and then the character, just terpri itself.
Yeah, I think it needs something. Let me just see. There's a optional string. Blah blah blah. I can send a thing.
Okay, let's see if that works.
Okay.
Oh.
So we have X. I can remove this.
Oh, put the terpri between the. No, you're doing
Yeah,
fine. You're doing
whatever. 0, 4, 0. So X, Y, and then the piece. So what the heck?
Wait,
The S
folks.
only
We
has
shouldn't have
this?
only 4 results.
Yeah, we shouldn't have just 4. We should have 9.
Yeah,
Man.
that's wrong.
Uh,
Oh.
oh, it's exactly what Commander said. We are not doing nested loops. We are doing 2 loops in parallel.
Oh no!
So we need to-
Ah.
that's stupid.
Oh,
Okay.
the Jew from the first should need 4, right?
Yeah.
Oh
So,
man.
we should just make like this. Oh man, I get it.
Oh, I
Uh,
see. Oh, that was quite
Oh,
nice too.
that's
no, but
yeah.
wait a second. What Nathan? What are you saying about 4, Nathan? I didn't get the 4 part.
No, was what Commander was saying. Like I was just rephrasing that instead of like doing like 4 4 with the Jew, we do
Oh, double
another
4.
loop
Ah,
inside the
okay.
first Jew.
No, I understood the number 4 when you said.
Oh, okay, sorry.
Ah,
Wait,
okay.
there is a evaluation aborted. Let me see. Compiled with errors.
Look at this indentation. Man.
What is that?
Thank you. The macro expansion broke somewhere. Let me see. For do.
Wait. Commander is saying something. So also replace 2 with below and remove minus.
Hmm?
Okay. So instead of 2, you use below, and
Huh.
you can remove the -1 from the loop's boundaries. Because we are doing array dimension -1. We can just do apparently below instead of 2, and then we can remove the -1.
Oh, okay.
Which is
Okay, like here,
yeah,
below, and
exactly.
here it's actually do.
Yeah.
Is that it?
No, but the 2, we still have 2 in the second loop. And you can remove the ones. Yeah, you can remove the
Yeah,
ones.
yeah.
Oh, okay, yeah, that's quite nice, yeah.
But I prefer using brackets and parentheses to differentiate between like inclusive and exclusive, Because okay, below and 2.
This actually.
However, I'm gonna I'm
Like
gonna know the
below
difference.
this value,
Still, the
it's like this
macro is
value
wrong.
minus
Hang
one.
on. So let's debug here.
Okay.
Let's see. So we have this problem. Look at this beauty.
Oh
Um,
man.
break on signals to intercept. For as a clause in a loop. Below is an unknown keyword. I probably did some.
Oh, so my commander is saying that we are returning the board inside the loop.
Oh, okay, this thing here. Now it's
Oh,
inside the.
parenthesis else.
Oh.
Parenthesis else
Yeah.
problems.
Yeah,
Okay,
that
so
was
here.
parenthesis problem.
All right.
Okay.
So this. I quite like this because you can actually see where things are, like the way it indents.
Well, when you have like a third Lisp PI, then you can
Oh, below is only with one L, guys. We are dumb. We don't know English.
see.
We don't know
Oh
English.
no.
Which is
No.
fair, I think.
Yeah, it's totally
Well.
fair.
Okay.
All right, now it
Oh,
Oh, we have the S.
oh,
We have the
yeah.
S.
can. I see.
Wait,
Oh,
it shouldn't
cool.
be there.
Let me commit this immediately.
Oh,
Actually, I
the
don't
guy
have
is
my
scared,
thing
man.
here.
You don't have what?
I don't have. I didn't set my thing, so I just go with it.
Okay.
Let's just trust that we are not gonna destroy what the commander did for us so far.
Okay, let's try to
Because we're not
understand
doing
why.
anything.
But let's try to understand why the S is dislocated, man. I'm confused.
Dislocated? No, it's right.
No,
It
it's
starts
not
on
in.
0.
No. But
Let's
it's
see.
not in the. It's not in the on the 4. On the 4.
Oh, it's
1, 2,
inverted.
3,
It's
4. So, okay. So we should start with one less because.
no, wait.
Okay, I think I get it because let me see. 0, 1, 2,
2, 3,
4.
4.
And then it starts on the 5th.
Yeah. We need to do some sort of -1 somewhere.
Well. Well. Well.
Wait,
You
is
know what I
that
will
is that
do,
I
right?
and J?
You know what I will do, right?
Yeah, you can do like that.
Wait.
No, but the X will not work.
Folks,
The X will not work. Because the X is
Oh.
0.
Yeah, so it's beaten -1. Oh, right. On the on the X it will break.
Yeah, and the
That's
X will
true.
break.
But wait, why is the X not breaking?
No, wait, folks. Is I and J really starting with 0?
We are assuming they are.
Can you print that just to be sure?
Wait.
Yeah,
what
we
is the
have
starting
there.
one?
We have there. You see, 0, 4, 0, Nathan. The first 0
Oh,
is the
yeah.
X. And then we have the.
Oh,
Wait.
below it will stop at 3. Okay. So the X, actually the X is this. Oh man, it didn't print the zeros as well. Let me see. Yeah, probably didn't. Let's just add as, I don't know. 4.
Yeah, put a 4. Yeah, that makes sense. That will make it easier to debug.
Oh, yeah, it's
Yeah,
Where are you
so
guys
it is
from? We are
printing.
from Brazil, Commander.
What the heck? 0, 1, 2, 3, 4. So now it's writing on the right position.
Wait,
What?
what changed?
But we didn't change anything, man.
I
What
just added a 4 here. It's like a C code that I wrote once that has
No.
the twins.
What do you mean?
Just run it again. I guess you
What do
hadn't.
you mean?
I guess you hadn't saved it or something.
Still didn't save it, yeah, because you have a 4 there. What do you
It's on the
mean?
right
Oh
Okay,
position.
yeah, now it's right.
Okay.
Okay, let's just accept the fact that it is non-deterministic.
Yeah, remove the print. Remove the prints. Remove the prints and let's
Oh,
let's
wait.
rotate the piece.
Oh yeah, it's right.
Remove the prints and let's rotate a piece.
I think we don't need this as well.
Yeah, but if
Okay.
you can commit already because we did like
Okay,
a
so
test.
please, Commander, do you know how to do transpose and multiplication with matrices, or are we gonna have to do that by hand? Please say that we know how to do this. It's like a function.
I think
Please.
I think he said in
That'd be
another
funny.
stream that we don't have it.
Oh man, I'm gonna be so sad.
Okay, so look at this. So the pieces, the block, for example, it has like this layer. So it's a start writing on this position, then it's shift. Like,
No, wait, what?
Hmm?
so it started writing the zeros in this line here.
Yeah.
You see?
Yeah, exactly. That's what's happening. Yeah.
So we can just ignore this or
Yeah,
try
just
to make
ignore
it prettier.
No,
would
this is
ignore.
just for debug. This is just for debugging purpose. There is not a built-in function for that in the standard. There's a library most likely, but I mean it's pretty easy. It's gonna be
We're
just
not allowed
verbose.
to use libraries.
It's gonna be just verbose.
Just OpenGL.
What do you mean?
It's gonna be like
No. Using a
Can we make
library is
moment?
a lot less verbose than like doing by
Can we
hand.
no, man, we cannot use a library. Just OpenGL. 'cause
Wait,
it's-
why? No. Fuck that idea, man.
No. Where's
Okay,
the
then.
fun? So we have.
No, wait,
Okay.
folks, wait. We will spend a bunch of time just to do like
No, not a
matrix
bunch of time, man.
multiplication.
we can
That-
do the monad though. We can just use this. We can make
Yeah.
a monad for that,
Let me
Nathan.
see here. So
Okay.
we made this thing for the presentation.
Yeah.
And this thing, it's flattening. So we just need to do something similar. We can make a similar sequence. Monad. But I'm just thinking here. I mean, I really dislike closure. It was basically like we were able to multiply stuff, you see? Like vectors. But we need to modify this a little bit to multiply matrices. because
Exactly,
multiplication
that's
of
the thing.
matrices- But I think if we can make vectorial
I think we can make it. I think we
calculations-
can make it.
If we can make vectorial calculations in Common-Lisp already, then that's gonna be fine. Because okay, so we have. I think I was making one with Nata.
Wait, Magetta, wasn't like Lisp back in the day known for doing like AI stuff?
Yeah.
Did
but,
you
like,
need it like
it
that
is-
kind of operations for?
probably, but like think about this. You're thinking. So we're gonna rob this.
Like which
Evil
Lisp it
function
was at the
here?
time?
I think it's called. There's like Lisp 1, Lisp 1.5, and then there's that Mac Lisp and a bunch of other Lisps, and then you have like.
Oh, so they
schemes,
probably
like,
had it,
pouring out in
right?
the middle. No,
Folks,
but, like,
let's
the idea is
focus
that
here.
the idea of the list computation is that you can do stuff like this. You see.
Hmm.
So it's like iterating over this thing here, but it's not to make multiplication of two things like this. No, this, not this, right? I mean, this. 1, 2, 3, like this. That's not the idea. At least I
We
think
need to
we
have an abstraction to do this,
See?
Nathan. That's the thing.
Okay.
But we can make this, and that's the thing we did the other day, man.
Yeah,
I
that's
just pasted
basically a
here. I
monad,
hope it's
right?
not cheating. This is
No,
easy
it is
to-
not cheating. It is not cheating. But I still think that we need to evaluate this, Maggot.
Oh, it
Is
just
this
works.
actually?
It just works. Okay, it just works. Very close. Okay. Okay. Let's
It
see.
just works.
Oh man, I love this thing because it's like closure is so different and ugly. But like Lisp and Common-Lisp, they're not that much different. So that's the benefit. And just get the other functions we were trying to use here.
No, but we need to
This
change the
thing-
monad though, because we know the
Yeah, we
matrix
will. I just want
multiplication
to test. I just want to
okay.
test them.
Okay, that's
Just
fine.
want to see if that will work. If that works, that will be amazing already.
Okay, so Commander and Ek, I don't know how to pronounce your name. I'm sorry, but do you two know what we are talking about? Like, while he's copying pasting the thing, we're gonna do the matrix multiplication instead of doing it by hand. We're gonna use an abstraction for that, which is called the monad. So
Let me see if it runs.
and
It
maybe
just works. What the heck? Okay, let's explain. Maybe people don't know about this. I don't know who's watching though. But anyway, a monad is an abstraction for basically on category theory that allows you to extend. I would say not extend the syntax. That's part of it, but it's a way to box and map elements. So it's basically a structure that has, let me define it like C type thing. So it's basically a thing that allows us to do bind operations. So this is the up arrow, and allow us to join. So join is return. Sorry, no, this is the unit. Sorry. Okay, let me just roll back. So we have the bind.
Just one note, Magit. I'm not sure if it would be useful for you to do those parallels with, oh, that's the up arrow or something, or
no, I think Mageta, the way to do this is to just like let's do it, and then later we show the results, and it's gonna be easy to understand.
Okay, I just want to explain these two basic things on the thing. Otherwise, we're gonna keep doing functions, and like people won't get the idea.
Yeah.
So we just need two functions. The first function is a bind, so we get the thing that is wrapped up among other things. It could be like I don't know, a value, like identity, like a let, for example, is exactly that. We have a let, and then we wanna get this, right? So x1, for example, and then you have y2, and then you have a return clause, which is like I don't know, addition of them both. So this, and this is exactly what we're doing here. So this is the cool part, and this allows us. So if we evolve this 3, if we evolve this 3, so we want to make something similar for handling sequences, so we can make computations with sequences seamless.
And okay, now I need to say a disclaimer. You can say that we can do matrix multiplications using 2 4s, right? Especially in our case, because the matrices are basically the same size, like 3 by 3 both. But then we want to use this opportunity of multiplying sequences, in this particular case lists, to just to explore a more advanced category 3 concept, which is monads. And then there's a bunch of monads like identity monad, and then sequence monad, and then option monads, and so on and so forth. I am proposing to let's just do Magit, and then we can just show the results, and it's going to be easy to understand.
Let me just explain what this bind is doing. So we're getting a function bind. So we're applying the bind thing to some value over a lambda, and then we apply inside this lambda another bind that binds another variable into another lambda, and this lambda is the final return. So I'm talking about this thing here. So this is the final return. So we just do the return instead of the bind thing with another lambda. So that's the idea. That's what this macro is expanding to. It's pretty ugly.
Okay, but let's just do it then. I think, like I said, I think it's complicated to explain in abstract terms. Let's just show what it does, and then
let me just delete these two things here.
Yeah, remove the
So
identity. Remove identity, man. We just want the sequence.
Yeah, so we need the sequence bind and the sequence return. So what would be the bind of the sequence? We want to get and map the thing, right?
Yeah.
We're gonna get, like, what is the type of M? M is like a random element, and F is an element that we want to apply inside the functor. I'll try to avoid the names.
No, but don't you have a
applying
sequence
the list.
as the sequence model already built in? I think I saw it when you were messing around
Oh,
with
yeah, I actually have on closure. Let me see.
Yeah, let's read the closure version.
Okay, closure, man. Here.
Okay,
This.
so
the bind is basically a function that gets n and f, so the monadic value f, we print, and then we flatten. I don't know how to do the flatten here though.
how do you flatten a list of lists? Is that what you want to know?
Yeah, like we get like for example a nested list.
Can't you use
Let's
that
see here.
destructor of lists?
Let's see here. 1, 2, 3, and then we do list 1, 2, 3.
No, not 1, 2, 3, 4, 5, 6.
Okay, it's bad to read. 4, 5, 6.
Yeah. How can we flatten these? How can we flatten the list of lists?
What? Then we don't have.
Okay, we're gonna have to search that.
Yeah.
Magenta, did you have like an operator to destruct / spread a list? You could iterate on a list during the spread.
Yeah, but then that needs to be recursive, going in branches, and that's what I don't want to do. Oh, we have a dependency for that. Oh man, kill me.
Wait, wait. Is flatten arbitrary nested lists? Isn't just
if it's
one
a
level?
Loop, no,
Okay, I don't think it's
because we
built
need to
in.
go-
I don't think it's
because
built in.
Because if we have another list here, for example, if you don't have another level, then it wouldn't flatten, you see? But like, we need this function here. I don't think we need this level though. Maybe not, but we can do it, man. Let's see. So this guy is doing receiving a list, and he checks if. I think this null checks if it's null, right?
Yeah.
So if it's null, if it's an atom, so it's just one guy. And if it's true, okay, this is the else. So like when it hits here, you already enter.
Yeah. And then you do
a loop for a appending to a flatten. Okay, calling it again. Okay, that's it. Cool.
Okay, but I have a question about the example there. We have a list with 1, 2, 3, and then the another element is another list.
Yeah, it could be like a bunch of lists because it's a bind, right? So the more we keep binding, the more it's gonna be nesting the lists.
Okay, but I think we need to flatten a list of lists. Is that right?
Wait, did I do this right? Oh, list. Wait, did I do?
Oh, now it makes sense. Now it makes a lot of sense.
Yeah.
Okay.
No,
Actually,
wait, Lemus. They can also be like not lists, like.
Yeah, like this.
It's
1,
because
2, 3.
it's because in static language you cannot do that, but there it makes sense. It's a single element or a list. If it's a single element, you just like.
No, what I'm confused is that you have inside the list 1, 2, 3, which are like numbers, and then the fourth element is another list.
Yeah, what is the problem? Like it's a dynamic programming.
Yeah, that's the thing. That's the thing that I'm forgetting. My brain is saying like this is wrong.
Look the definition of the flatten, checking for the atom that you will like put in your mind.
All right.
Holy, nice.
Cool. All right.
Okay, so you know how to flatten the list.
All right. Where's the function? Oh, there. Let's just paste it here.
Yeah, so Commander did the multiplication, the transposing by himself with loops.
Oh man.
Wait, Commander, just wait. You go believe in us, man. Believe in us. We're not crazy that much.
Oh.
We are just a little bit.
Okay, so let's see. So we need to flatten. We need to flatten. Remove this fun call. So flatten the result that will be applied to a map over the value.
Do we have the map?
I think we do.
Have the map. If we have then I'm going crazy.
FM.
But here's the thing. Can I just put F here? I think we can. Because it's going to be a parameter. Because we have to do this to pass the function as a parameter. But I think in here we don't. That's sad. I don't know. Because this is a function.
Can we read the documentation of map?
Yeah, but no, here's the thing. Like, when you do a lambda in here, like, let me do this. I don't know. It just returns 2. So when you do a lambda, if I eval, it's just a function. See? It's just a lambda.
Yeah, okay, that's fine.
And then, like, to pass it as a parameter, if you just like pass inside the thing, like let me see. There I don't have anything that like. Oh, anyway, you just do this here. At least
This
in
is
the
how
list.
you pass a function as a. This is how you make a
Actually-
function a high order function.
I don't think so here because it's showing the same thing. See, but it's I don't know if it's just the eval or you can pass it like this. I know in Lisp you need to do this.
Okay, so
Let's see.
Commander also saying, damn crazy Hasklers doing their monads.
Oh,
That is a thing that I'm curious about, like on how
You need to find a
Commander
reason to
got
use it.
interested in like Common-Lisp, because he said
Oh, yeah,
he works with
Common-Lisp.
C++, right?
Mm-hmm. Good
Yeah.
question.
Okay, so Commander also says that you need to specify the return type for map, apparently.
Oh,
The return
How
type
you
for
the
a
heck
map?
specify a type here?
Return type, result type, function. Okay, like list. I think it's a symbol, like list, something like this.
oh,
Okay.
Let's just see if this works.
If this works,
I'm
that's
not,
so
I'm not any confident.
unusual.
It's so unusual. That's
Yeah,
a way, funny way to say
but
ugly.
like no, not really. Like, because what about if I want to like do a mapping and the callback it's like returning different types? Do I have like an object type to specify any type?
Good question. I don't know. Oh, I think. Oh, I don't know. Oh wait, what did I paste here? Good question. Good question that I would just ignore. 3. Let me see. Now is the time of truth. Lambda, we're gonna take. Let's just do like a multiplication.
wait.
So we're gonna take-
Is this the right order? Because I think F comes first, don't?
Hang on. F comes first.
Yeah, because you're
Actually,
passing
the
the.
monadic value first. F sharp, man.
Oh, okay. Now it
Ah.
makes sense.
Yeah.
Okay, so
So,
Commander says
doesn't
that
matter.
the language has types. It has types and parameterized types.
F is undefined.
F is undefined.
undefined, probably because it didn't do this. Let's see. F is still undefined. I think we don't need to do this though.
Okay, let's try that. Nope.
Undefined function x plus 2. Oh, Polish notation. All right. So we have it now. Can
Okay,
we
it worked. It.
Oh wait. Here, can we do with a list of lists? Let's see, list 4, 5, 6, and actually, oh wait, deleted one. So 6 will be list of 6, 7, 8.
It's not
So
a
it didn't
type
go beyond
number.
the first level. I think.
Oh, it's because you are mapping and then flattening. Then you have a problem with types, right?
Yeah. So
How
we
is
need
it
to-
implemented in Clojure? Is it map then flatten, or is it the opposite?
I think if.
It's
Good
mapping and
question.
flattening. It's mapping and flattening.
Yeah.
I think I remember.
That is a
It's not-
difference. Because
I think.
in our case, the types just don't.
Yeah, because it's trying to map, it's trying to do something that it's not.
But
Trying to-
like,
because the
would be a
flats-
problem to change that order to flatten and then map it?
I don't think so. Let's see. Map, and then here, right? Flatten M. Okay.
No.
Just works.
Okay, so
so
what
we
we
can
did,
swap
what we did
the order.
here, we are flattening and then mapping. So we are 1, 2, 3, 4,
Yeah.
5, 6, 7, 8, and then times 2 every one. Yeah, it worked.
Mm-hmm. Okay, so
now-
in the return, we just need to wrap this in a list. So we just need to do this.
But it's gonna be a list of lists. Oh, not or not.
No. And
Oh,
here,
it's
this
oh,
is
it's because
just
we don't
unit.
have. No, we don't have.
Because
We are
it's
not
the
doing the
result of
monad
this.
do. We're not doing the monad do. I'm dumb. Okay. Okay. No, it makes sense. It makes
Okay,
sense.
mhm. So let's see this here. So we can make a list of 1, 2, 3. And we can define it here by list.
A list of 3, 4, 5. Man, if this works, 1, 2, 3 is on a
Is that
type
a
number.
number?
Go back. I think you did. No, wait. It. Uh.
Let me just look at the closure thingy. So we have 2. We're multiplying. Oh, actually, it is a function. Do we have any difference? I don't think. Okay, I just did this so I would have like to get the lambda and do like this. But
Holy
this is actually a function, so it doesn't matter.
Okay, so what's the problem again?
So the problem is that it's not identifying something as a number. Like
Which
the
is
value
range.
1, 2, 3, so x is not just the type number. And where was it on the
Wait.
plus?
You have lists and you are trying to sum the lists.
Yeah.
That's wrong. Just
Oh wait,
No.
the flatten is wrong.
wait.
Is it wrong?
Because do we need to do this? Oh man, if you do flatten.
Wait. Inside monad Jew, you don't have anything regarding the monad sequence.
Oh man, I'm just thank you, Nata. It's because I was
You
going,
don't
we
get
are
the
not using the
identity.
access.
We are dumb.
We're dumb. Okay.
We are dead dumb.
Oh man.
I also basically use Rust, Go, and Haskell. Okay, so we can help you with the Haskell and Rust, Commander. That's a thing. Because Nathan knows Rust, and I know Haskell.
No, I don't really know Rust.
You know more than me, so it's fine.
All right, so we
It
did a
worked!
moment just to multiply and add numbers. Cool. Yeah,
Nerds.
Okay, but there's a problem, right? The order of the multiplication matters.
Yes.
How are you gonna do that?
What do you mean, Miles?
Because a multiplication of matrix is not just the same thing as doing multiplication of any because
Okay, the order matters, but
go back to the result, Magetta. The monad do result, just to me to explain. You see, so we are picking each one of the elements in the first list and multiplying by all the elements in the second.
okay.
So for instance, you have 3, 4, 5 in the beginning, right? Look at the bottom. And then we have 2 times everything else, and then it's gonna be 6, 8, 10. And then 3 times everything else. 9, 12, 15.
Okay.
And by the way, this is the power of the monads, Commander. This is, you see, we did exactly as 2 loops, but this abstraction is more powerful because we don't have to control anymore, like how many 4s, you know. The thing is gonna do that for us.
Yeah, I could do like I don't know, another one here.
Yeah, we can do another one. You see, it's arbitrarily extensible, and that's the beautiness of it, basically.
It's gonna be bloated as well, but it does. Not bloated,
Look at that.
right? It's
Just
gonna
look
be.
at that.
Yeah.
Look at that. Just look at that.
Okay,
so
okay, that's quite
recursive
nice,
definitions
actually.
here as well. Let me see.
this is the power of monads, Nathan.
Yeah, I can do recursive definitions.
Okay, so what we need to do, Nathan, we don't want to do this what we are doing, like one times everybody else. What we want to do is the first row multiply like the first element of the first row multiplying by the first element of the first column.
Okay.
And then that's the thing. You see that it's not exactly the same as doing like everybody else times everybody else. We need to control the multiplication, but I don't know how we're gonna do this with the monad. That's what I don't know yet.
Wait, guys.
We can control by the by what? By selecting the lines. Because here's the thing, like we just need to get the lines and the columns, right? And know which one we're multiplying by which. That's the problem.
Wait.
Right?
I thought that you guys were doing this sequence monad because it was like how can I say, like trivial from that to multiply 2 matrices.
But yeah, it is.
No, but that's the thing. We can multiply a list of lists, which is basically our matrix, right? Our matrix is basically an array of array.
No, I'm talking about the like operation in mathematics.
Yeah,
like...
that is what I don't know how to do yet.
Oh fuck, man.
So I need to discuss with Magetta. Magetta, how the heck are we gonna do that, man? Because you don't have access to the indexes.
Yeah, let me just remember. So, oh man.
No, that page is enough to remember. That page is enough to remember.
Okay.
So look, if you multiply the first row with the first column,
Hang on, let me just sell my data.
okay.
Okay.
so pay attention to the first row, of the matrix on the left, and the first
Okay.
column of the second matrix on the right.
It's gonna be 1, 1.
No.
0. Wait.
0.
0. Okay.
Okay.
It's a multiplication by each and addition, right?
No. There is no addition. Here, there's no addition. It's like the first element of the first row is going to multiply by the first element of the first column, and that's going to be the first element of the new matrix or after the equal. So, for instance, 1 times 0. So the 1, highlight the 1. Yes, highlight times that is 0, right? Do you agree?
Okay. With this 0.
So C on the right, the first element of the first row of the first column, it's 0.
Yeah.
The result, look at the result as well.
Yeah. Okay.
And then you do 0, 0, 0 of this first row of the first matrix, the second element of the first row.
The second element of the first,
row of the guy on the the guy on the left.
It's better to put on like Google image because
Yeah, I was thinking
like
it's better,
ones
like,
and zeros is very
Wikipedia,
confusing, man.
Wikipedia. That's
Like
better because it
Google
shows the
image
indexes.
probably has a
Here. So it is, I think here. So it is basically a C that is, let me increase the image. Can you click? Oh, I can't zoom in. Thank you.
No, but there is. Oh, I forgot. No, there is just the sum after. I forgot to say that.
So EE. No. EJ.
1 1.
EJ.
Yes.
So 1 1 1 1, and then we have N going from the rows. No, from the columns of this, right? So we get the row, and then we get the column.
Yeah. And then you multiply 1
by each.
Yes. And then you sum them up.
Okay.
Okay, so that's it. If you go back there now, it's gonna make sense, I think.
Okay, I get it. So we need to multiply. So what we're doing here is actually multiplying
every element of the matrix with every other element of the matrix. We need to have a way to control those, you see. And the thing that maybe makes it complicated, that I think probably Commander did it in his implementation, is the fact that with using force, we actually have the indexes.
Yeah, that's true. Just one thing, I don't know if this monad accepts. Yes, it does. So we can pass just a value here, and we can do the same. Like you see, let me do that too. So
like,
it's like
guys, one second. Like you are doing the giving operation in the order that you said. I have the first of the first list, and then I apply the operation on this and all the others from the second list. But that operation that we have there, in this case the times operator, multiplication operator, it can be any function, right?
Yeah, it can be any function.
Yeah.
Okay. So we know in which element he's applying like at the time. Can't we look at these and see if that is a function that could like do the output that we want?
Can you try to rephrase what you said?
Okay.
Yeah,
so what your like monad is doing is you have like two lists and you are getting some elements, right? So the first element will be like the first of the first list with the first of the second list, and then you go to a second element on the second list and you do it, right?
Yeah.
And in those occasions, you are calling the callback. In this case, the callback is multiplication. So it could be an arbitrary function, right?
Could be.
Since you know what is the values that the callback will be called, you can like list those values or just imagine and see, is there a given function that would result in the multiplication that we want?
That's the thing, there isn't, because the only way to do what we want is to have access to the positions of the elements.
Yeah, then we can do two things. Either to put the position of the
Oh!
elements inside the list itself.
But no, I'm so dumb. We are so dumb, Mageta. Holy fuck.
What?
Dude, what we can do is the following. The monad do will pick two matrices, and then we can make a function instead of multiplication. That was not what I was going to say. We can switch from the multiplication. We can make our custom function, and then in that function,
Wait. My phone is. I think the battery is dying. Can you say it again?
yes. So instead of the monad handling the indexes and things like that or whatever the hell, we could make an arbitrary function instead of times of multiplication. We can make an arbitrary function, and inside that function we do there we need to do force. Now we need a way to get an index of the element.
Oh wait,
You
folks,
see?
but well,
So,
I
I
know.
think it doesn't worth then doing this.
Yeah,
That's
I
the
also
thing.
think the same.
That's the thing.
I get the thing, but I think we were thinking of this, or we try to alter this behavior here of the bind, because we can do it.
Yeah,
We just
then
need to
it's not the
alter-
same monad anymore, right?
No, it's gonna be a different monad, but that would be awesome because we're gonna be
Do we
making a
have
monad
an-
that is not
So,
common, Manhattan. Because the sequence monad is like
matrix
vanilla, you know.
monad. Let's see if somebody did that. Applicative functor, which is not a monad.
The first
That's
result,
awesome.
how encouraging.
Yeah, thank you. Yeah, but I think
But don't you
think
need
it's
to think
doable
about the
because you just
elements
need to-
that you are manipulating and see if it fits on, oh, okay, this is a X and Y, then we can do those operations in it.
oh man, we have a
That's the
computer.
thing. So Mageta was speculating that maybe if we change the binding, we could kind of already do some sort of handling of those things, Nathan. But
No,
apparently
but
there
I
isn't a
mean,
way.
A
like,
precedence, for example.
hmm?
Like, for example, imagine you have, I don't know, precedence is not a good thing.
Wait, 1 second. Like, okay, you have like elements that you are manipulating, like some containers, right? For example, lists. In our case, they will be like matrices. Don't you need to observe those elements and see if they have like certain characteristics or requirements to, oh, this is a X. Then I can do a
Oh yeah,
monad
you
for-
know, like a sum monad, yes, a maybe. But here, I'm not doing that.
No, what I mean
You're
is,
just flattening
I
it,
have the
that's what I mean.
sum, I have the list, and I can say that they are monads because of they attend to those requirements or they have those characteristics. So we could be thinking about matrix, and in the end of the
Yeah,
day,
okay,
maybe
I
they
get-
don't have those requirements.
Yeah, I get what you're saying.
Yeah,
Let
but
me
that's the
just-
thing. So that would be really sad because then we don't have a functional way of doing this. Like not a functional way. We don't have a very elegant solution. We need to do the force. Like
Use fancy. Use the word fancy.
no, it's not fancy.
It's
like
not
like-
necessarily elegant.
No, it is elegant because
Okay,
it's
so-
arbitrarily extensible, man. How the heck that's not that elegant?
Okay.
You don't have to do a bunch of fours. You don't have to
You're
control.
just distilling.
I
hatred on
agree,
terms.
but it's also fancy.
Okay, some things that are elegant are also fancy. I can agree with that. I can stand by that. But holy man, that would be so sad. So sad.
Like I see the intention of using something like that because of learning and a bunch of stuff. But regarding going to the project, I think it was a poor decision.
So I'm just trying to print so we can see if it is a good idea. I started to think it is not. But look here, like we can control this, you see? Like that's what Nathan was sort of talking about, because we can check here, right? What is the thing?
Folks, like
Yeah.
if you guys want to do with this, I might have an idea. Like see the list that you are getting as input, you could manipulate those to include like indexes or something.
Oh,
Not sure if that
Yeah.
would help. Like for
how was the
instance,
intermit, right?
you could like map
No,
a
Tech
list.
right. I
Sure.
think it's Tech right.
Oh, to print, right?
Yeah.
Yeah, like for instance, you can map a list to be a list of tuples that has the element and the index. For
And the
instance.
index, yeah. I think we could manipulate that, but I don't know. Maybe not Magetta. We should have thought this a little bit more thoroughly, because if we discovered in the beginning that okay, people already tried to do the matrix monad and doesn't work because whatever, I think that we should just pick Commander's code and try to understand it, and then we are done. You see?
Yeah, I agree. Let me just do this because we already did this, man. I just want to see if we can control the thing. So we have like the first print. I'm just printing here. So ignore. I think the last one is the result. I don't know if it's printing though. I think it prints in there. Okay, it's not printing here. So we just have 1, 2, 3, which is x, and then we have y. And then we have the multiplication again and again for each element here. So if we add the new guy here, then we're going to have 4. You see?
Yeah. Try to do it with a 2D arrays. Instead of lists, just put 2D, like a list inside a list, and a list inside a list in both dependencies, just to test a matrix, whatever.
You're talking like this?
Yeah, a list of lists. Yeah.
Result will be flattened, right?
I think it will flatten, yeah. So it doesn't really matter. Well, let's see.
No, but I just want to see what we do have control
We can
on.
change the flatten, yeah. Okay.
And change the unit to the second. Okay, it doesn't matter.
Both, yeah, it doesn't matter, but let's just do 4.
Yeah.
5, 6.
Yeah, matrices are not worth it. They are not worth it, the monad power.
So monads are useless. That's what you mean.
Pretty much.
They are not worth the power, man. Okay.
Probably this will break. Yeah.
Nah, this will break.
Okay, so we did this.
Wait. The map is we need to, the map on the bind is that the first element is a type, right? But the type is wrong. We want a multiplication of a list of lists should be list of lists in the matrix.
No.
No, wait,
Like algebraic types, Cartesian products. So no, it's just like a list. It will just check what is the utmost thing.
No. Two matrices being represented by a list of lists. The result of that is also a list of lists.
Yeah, but
Am I wrong?
You're thinking of types here as something like Haskell, man. Like
No. I'm
list of.
Yeah. Okay, that's correct. I'm actually thinking about putting there a list of lists.
So yeah, I think it's better to just drop this actually.
Yeah, folks. One note: we have like 10 minutes for
10 minutes
like
left.
9 p.m.
Yeah. So, oops.
You're gonna have to do Sunday again, man.
Not really.
Yeah, because we didn't complete rotation.
Wait. We don't need to rush it, man. Like, we actually don't need to rush it.
But we still have OpenGL, Nata. We don't understand.
But, like, what is the problem? We are not trying to deliver a project to someone, man. I know that you want to do nice projects after this one, but man, let's like do in our time, right?
Yeah, go bots.
So where's the code? Can somebody paste here?
I will send to you on Discord.
I think I shared on Visual Studio.
There it is.
Oh, you're not here.
No, I'm not here. No, but there it is, the code. And again, thanks Commander, right?
Man, Commander gave me like the straight, simple solution, right? And
yeah, and we are being autistic.
You will get cancelled, Magetta.
Yeah, man, don't care.
No, remove the flatten as well. The flatten is not necessary anymore. Oh man, so sad. Can we understand this? What is destruction binding? What is destruction bind?
Let's see.
Well, that's pattern matching, right?
So okay, so it's getting the dimensions out of this thing. Oh, this is cool.
Why
it's
is
like
that not built in? That needs a function for it. Okay.
Oh, everything is the language is small, right? So
well,
it's like this. right?
Wait.
Yeah, that's the same thing. That's the same.
Wait, Lems, but you always need a kind of a quote-unquote function. Being the let
Yeah.
or the match, you are using things to do that.
I know, but I prefer let.
it
Look at
makes
the size of
sure-
this name, man. Look at this. Look at
So-
this.
So focus. So
Okay.
it goes and it makes sure that both are okay. So you can actually make the multiplication. So you need to match if they both are the same.
No, not the same.
No,
Actually, Commander
if
is doing
they
the.
are
No,
not
the
the
lines-
same,
the
you
lines-
cannot multiply. Then
No,
you
no.
fail.
No.
And the
No, they don't
the
need to be the
columns.
same. They don't need
the
to
lines
go
and
to
the columns
Wikipedia.
of one of the other.
Exactly,
need to be
the lines
same.
and the columns. Do you understand that, Nata?
Yeah.
Wait, I was not.
Okay,
Like you
to
can
do
have a
matrix
X-
multiplication, you need to
Let's
have.
see.
Oh no,
one
wait.
restriction.
I got it. Like if
Okay.
it's not compatible, you just like
Yeah,
fail it.
it's compatibility
Yeah.
basically. Yeah.
Let me see. So now we have a let that gets the rest. I think it's rest of the list of m. Okay, so it's just making an array with these shapes. And
Yeah.
then
Okay. And then he's
below-
mutating the rest probably. Yeah. He's mutating the
and then
rest
he's
after.
just getting the position. Okay, he sets the position with the thing that he iterates. Now, okay, this is the weird part. Let me
Wait.
see.
He's
Okay, this is the addition, I think.
No, wait.
Right? So we need to multiply the sum of additions. A sum of additions. We need to multiply each element by. Let's look at outmost first.
Yeah,
So we're
I think it makes
multiplying
sense.
I and K and J, and I. Okay, K is this guy that goes on the column of the second.
Okay,
it's the rows of the second.
I go
columns.
down.
This is columns of the first.
No. Go down on with the cursor and open a comment. Semicolon. I is to iterating the rows
Oh,
of
you
the
want
first.
me to do like this?
No. Yeah, it could be there, but I don't know.
Okay, let me just get it here.
This is
Iterating
for
over. Actually,
over.
we don't need to do this here, man. We can do here.
Yeah. So
Actually, it's pretty explanatory. So N1 is the rows of this
the
column.
first. No, but the I is iterating through that.
columns.
So put that
And then-
I somewhere. I is iterating through the rows of the first. Rows of the first.
One.
The J is iterating through the columns of the second.
Rows of.
No. It's columns. This is column.
Yes, it's columns. Yes.
Columns.
Rows of 2. Okay.
Yeah. And
And
then
here-
the K is iterating through the
Columns of 1.
one. And then the sum is doing the sum on line the line below. You see there? Column sum.
Yeah.
So that's the addition, right? And then the I is iterating through the rows of 1, and then the K with the columns of 1, which is fine. So we are iterating through the first row itself. And then of the first. So we are iterating the entire row of the first, multiplying that
Yeah.
the-
Okay. Again.
and by the columns. Wait. I see. Do you understood, Nathan? Did you understand this?
Wait, I was not paying attention, man. I was handling something here.
Okay. So I'm going to try to explain. We have 3 loops, Nathan. Okay.
Okay.
One loop to iterate through the elements of the rows of the first matrix. Okay, which is I. Okay, and then we have J, which is to iterating through the columns of the second matrix. Okay, and then to do the multiplication itself is the third, and the multiplication and the sum is the third loop, which is K. The K is iterating through the columns of 1 of the first matrix.
Okay, I see.
And then we are doing pick each element of the rows of the first matrix and multiply that by the elements in the column of the second matrix. And then we multiply those and then we sum them up.
Okay.
That's what we are doing with these 3 loops. Can we have an example?
We could have made the monad do these expansions. Right?
No, man, don't even start with that.
Yeah.
We can do that offline. Magit.
Yeah. Okay.
Okay, so let's make a test. So can we
Yeah, I
call?
already ran.
What is this doing then?
By the way, what are the multiplications that we need to do in order to do the...
We need to do two
4 by 4.
things. Yeah, multiply by 4 by 4.
So we need to multiply.
No. They
This is the problem.
They are all 0, right?
The result. Yeah, it's all zeros. Yes.
yeah.
But I don't have an example here.
We need
But
a matrix.
We need to rotate now. So to
Okay.
rotate.
No, we need to
specifically-
transpose. We need to transpose. And if you go back,
Okay, yes. So the element is like.
yeah, go to the code.
this,
Go
so
to
it's
the
transposed, so
commander's
it's
code,
like-
man. Just go to commander's code.
Okay.
Look at the first function.
The first.
No. The
function.
first function. The commander's code in the browser.
Oh, okay.
Look at the first function.
Oh, he already.
Oh, no.
Oh man, he's so fast here.
he
like
already did the transpose.
Let's see. Transpose matrix. The search should bind mn array
Okay.
dimensions matrix. Loop
Okay.
below.
Okay, so I is iterating through the rows, and J is probably iterating through.
Okay, so the function that he talked about before. So let's just see the docs here.
Yeah.
To rotate f takes any number of set f file place expressions, evaluates all the expressions in turn, then assigns each place of the value of the form of its right. The right.
We need an example. We need an example to understand this. This is bad.
Can you get the example at the Discord, Linus?
No, it's pretty easy. Just do rotate F and then a list of elements.
Oh, yeah.
Yeah,
True.
but we need to set. But I think I have alpha here. Oh, cool. We have alpha. Rotate F, but we need to pass the.
Wait, you need
Yeah.
more than one, right? So...
Oh, it is in place, right? So E. Okay, so we rotated a B and A. It was like on the. Did it rotate? I think it.
No, I didn't rotate. You need to pick one of those. Do rotate in the first list of lists. Because alpha is a list of lists. Pick the first and then rotate.
Okay, pick the first. So A ref. Okay, I get it. All right. A ref.
A ref, alpha 0.
These- Let's pick the 0, 0.
No, it's only 1 0, man, not 2 zeros.
Why?
Yeah, what? Just 1 0. Just test that.
Just rotate one list to me.
Yeah. Okay, so apparently this is not how it works.
Doesn't he rotate by setting stuff?
Oh, he's saying that this is not a function, it's a macro, so it needs variables or places.
Oh, yeah.
So okay, so we can't use alpha. We can't use alpha. We need to do it manually, man. Ah.
I don't get why we can't use alpha.
Like, see, the way he's doing is by, like, setting one in the other, right? So they cannot be, like, straight values.
Can you repeat that, Anton?
I think
Okay, I get
that
it.
the way they are doing is, like, by setting one in the other. So they need,
Yeah.
so it cannot be, like, values.
Ah.
So I think it is rotating. Like, see that it's one here IJ and here's JI.
Yeah.
So let's see here.
But I
But,
want
like,
to
we need
understand that still, man.
Man,
I
it's
want
like,
to rotate
do you
them.
know when you, like, do, like, what's the name? It's not switch. When you have, like, A, B, and you want, like, to switch the values between those, and you do, like, a temp, and you do that, like, it's kind of less that, but not exactly. You are not, like, just switching one by the other. We are doing this quote-unquote rotation.
Folks, I need to go. Because I got.
Yeah, me also.
So let's just save it here and let's see what we can.
Okay,
let's
so
do this offline. Like, let's try to understand this offline.
yeah, let's try to understand this offline. No problem. Because I want to understand everything that we are picking from Commander because we're not doing it by ourselves. Which is, I don't know how I feel like about that. I need to
It's
think
not,
about
it's
it.
not bad, really. It's like pair programming.
No, it is, but I think we
No, we
learn
need to
more when you
understand.
suffer. The
Yeah.
suffering is part of the learning.
That is true. Oh, but at least we could spawn the piece and almost rotate. So
Yeah,
that
we need
is-
just need to
that is
pick
like
a.
two things.
If the two functions are working, we just need to make the
Here's where we are gonna suffer, and here's the ultimate hell.
Yeah, I think that suffer will only be like the last one, man.
Okay, so yeah, so let's finish things up here. So Nathan, you can finish things and think
Okay.
again. Thanks, Commander, the wise guy on Lisp. Uh, the guy that knows everything apparently.
Yeah, my friends. So I'll be going. See ya.